Hello all, today in this video I'm going to provide a demo video for heart disease XAI with a machine learning algorithm. Previously with the same heart disease I have worked with random forest and support vector mission, and based on that we have made a conclusion that when compared to random forest and support vector mission, random forest is providing better results. And now we are going to work with another machine learning algorithm, and we are going to compare the with random forest and support vector mission to just confirm that which machine learning algorithm is going to provide better results. For that, initially we are just importing the libraries like import OS and import warnings, NumPy, Pandas, and then we are just reading our data set. It is a heart disease data set which I downloaded from Kaggle. Then I'm making to display the head values. You can see mostly everything is numerical values here. The last target variable we will be considering as an y variable, and the every others we will be considering as the x variables. And then we are just declaring the info of the data set to find which type or data set is. Mostly it is integer and float only. Then we are finding if any null values is there, so no null values is in our data set. Then as I said, we are declaring the x value and y value. In the x value, apart from the target variable, we are choosing every other variables. For that we are just dropping the target variable, and in the y variable we are just choosing the target variable only. And then in order to create functions, variables like xtrain, xtest, ytrain and ytest, we are making with the train test split function, and in that we are giving the test size as 20%, and the remaining 80% will be moved automatically for training. Then here also we are going to make an XAI representation. For that we want to make an lime import library, and then for the using the lime library we are going to call a variable called explainer. This variable, by using this variable only, we are going to display the XAI graph. Then apart from that, we are also going to display the performance metrics parameters like accuracy, precision, recall, F1 score, support, etc. For that, we are going to import the libraries like accuracy, score, classification report, and confusion matrix. And then previously we have worked with the random forest. So you can see over there, here this is the result of random forest. We are getting nearly 100% accuracy with the data set we are using here. And then we have worked with support vector mission also. With support vector mission we are getting only 75% accuracy. Now we can see the description for naive base. So initially we are just importing the library which is needed for naive base, and then we are calling the naive base function. Then we are training and testing or machine learning model. For training we are using the fit function, and for testing we are using the predict function. And then we are making to display the accuracy score and the confusion matrix. So this is the confusion matrix for the naive Bayes algorithm for this particular data set. And then we are printing the classification report, that is the values for precision, recall, F1 score and support. From this we can just make to a conclusion that compared to random forest, support vector mission and naive Bayes, random forest is providing better result. And after that naive Bayes takes the place, and after that only support vector mission can be placed, since it's having nearly 75% accuracy. Based on the data set it may vary also. As of now, random forest is providing better results. And then we are going to display the lime representation. For that we have split, making the value j as 5, and the number of features as 15, and the number of features as 7. Then we are going to, here we can just get the values for intercept, prediction local and also right. Then we are going to the predictions. In the prediction we are going to display the 7 features over here. By using feature and value, you can see it will have nearly 7 features. If you want some different number of features, means you can just change here the number of features as 5 or 7 or 9 as per your wish. And then since we are having seven features, here also the values of seven features will be displayed. So in the next code we will be seeing with knn. K means nearest neighbor, with the same algorithm, same data set. And by this we can just make a conclusion that we can also work with other three the works which we have done as of now, and we can just make a comparison with all four. Thank you.